Hello everyone. In this video, we're going to discuss this problem E in Minlexes of Codeforces round 675 deep 2. So the approach we will going to discuss in this problem will be that as told by the editorial, the approach by hashing and dynamic programming. So there are other ways to solve the problem as well, and that way makes the problem like 2000 rated. But because we are solving this problem in the way as told by the author's approach, that makes the problem a truly a 2700 problem. So that's why we're going to now discuss this 2700 way of solving this 2700 problem. So what the problem is that we are given a string having length 10 to the power 5, and then what we have to do, we have to select for each length of the string, like we have to output a number, output a string and also a number. So what number and what string we have to output for a given length is that for a given length we can select arbitrary number of pairs at position I and I plus 1, such that the following condition should satisfy: that the position is valid. First of all, it should lie in the string, and also the positions are the character on those positions are equal. And other thing is, like, we cannot select a pair again. Like for example, we selected like one pair with indexes, let us say I and I plus 1. Then we cannot select I plus 1 and I plus 2 in that way, that we cannot make the length odd and then we can do the operation that we want to do. And after that, after selecting that pair, we can remove the pair if and only if removing the pair making can make the string lexicographically smaller. Otherwise, if not removing it makes it lexicographically smaller, we will keep then that both characters at position I and I plus 1. So let us now discuss this approach of the author in the whiteboard. So what we need to understand first of all is like first of all a definition, basic definition, which is a hashing. So how we calculate the hash of a string? So we calculate the hash of a string as using this formula as 0, that is the character at position 0. Actually it's not the character, it's the value, and we used to give the values of the Latin lowercase letters from A to Z as 1 to 26. So this will be the corresponding values, that is the values at the value at the position 0 plus value at the position 1 multiplied by a prime number. We used to take a prime number when there are only lowercase letters around 31, or some in this problem we will take this prime number 29. 29 is also big enough, like it's also bigger than 26, so it's also a nice prime number for this problem. And also then we will take finally a mod m. It is like s0 s1 p s2 p square sn minus 1 pn minus 1 and then mod m. The way it is represented, it's like similar to polynomial, so that's why it's called a polynomial rolling hash function in this problem. And we will gonna calculate the hash from the back side, from the suffix side. Like here we will give the power of p to be 0, and here we'll give the power of p to be n minus 1 for a suffix of length n. All right, so this is the one definition we will need in this problem. Other thing now we'll discuss in the whiteboard. So we will need two parameters in this problem. One parameter is described as hash ij, parameter hash ij, and other thing will be we need will be next ij. So what this hash ij and next ij is, we will now describe this in a moment. So next ij, quickly, right man. So yeah, so hash ij denotes the like, let us say we have the answer starting from the position I. Then the hash ij denotes that the value of the hash starting from the index I of length 2 to the power j. That is, let us say we have this string, like we have this string, yeah, we have this string s0 s1 s2. Let us say in the middle we get this si, right? So the value of the hash starting from the index I up to length si plus 2 raised to power j. So this part of the 2 to the power j, this part of the string, we will calculate the hash, and that we denote as hash ij, right? So what this next ij is, next ij is the position in the string starting from the index I of the answer. Like for example, in this case, let us say answer start from the position si. So starting from the position I, this is the position. This denotes the position after which after the length 2 to the power j, that is this position. So this position is denoted by next ij, and the value of the hash from si to si plus 2j is denoted by hash ij, right? So why we need these two things? One thing is, like for example, is that this the approach to solve this problem is like this. We will gonna traverse the string from backwards. Like let us say we will traverse the string from this direction, the suffix direction. Initially we will store the answer for the length 1 and then 2, and all the way let us assume that we have already the answer for the index I plus 1. Right. Now when we have to calculate the answer for the index I, we will compare Si and Si plus 1. If our Si and Si plus 1 are equal, in that case the answer will be either we have to include Si and Si plus 1, Si and the answer of I plus 1, or otherwise either this will be Si plus the answer of I plus 1. Otherwise, because that can make that means that we are keeping the character at the position I, and we are not removing the character si and si plus 1. Or if this is not max, like if we are copy very smaller, then the answer will be this, removing these characters si and si plus 1. That is the answer for the suffix starting from I plus 2. So if this is there, this condition is there, then the answer for the index I, that is the suffix starting from the index I, will be the minimum of these two. Otherwise, if otherwise si is not equal to si plus 1, then the answer will be simply, we have to include that character at position I, and also the answer at the position I plus 1, so which will be this part. So this will be here when si is not equal to si plus 1. So now we have now discussed the variables that you will need, and also the way to solve this problem in the dynamic programming approach. But there is one thing we need to discuss more. Like when we have this condition that that we have to kind of like output the answer as the minimum of two strings, that is of one string and this is the second string. So then to quickly compare two, if we have to compare two strings of length n, then it will take order of n if we compare the character by character in the worst case, right? And if we have to make n comparisons, because let us say assume that si is equal to si plus 1 for all the n in the string, then we have to make n comparisons, and each comparison takes order of n time, which will be order of n square time, which will exceed the time limit. So the approach it is described as binary lift in this problem of calculating the hash value for the for the suffix starting at index I for the length 2 to the power j. And this approach it does what is, like let us take, we have to compare two strings. Let us take this is one string, and let us take this is another string. Let us take this is as string and this is t string. So what we're going to do, is like we will going to have the value of the hash starting at index I, starting at the first index, and up to length 2 to the power some 2 to the power some length. Similarly, we will have the hash value starting at first index for the string t up to some length 2 to the power m, which is not exceeding the total length of the string t or s. Then if the hash value of the first and second are equal, then what we're going to do, we will going to shift our index after the length up to which we have compared the hash, right? And then we will compare again the hash value starting at this index for length up to 2 to the power m minus 1, if we have compared 2 to the power m here. And then if we find now that the value of hash is not equal for 2 to the power m minus 1 length, then we will just simply compare the character at this position and this position. If this position character is less than this position, let us take that this is the value, this f string represent the index from I, and key string represent the index from I plus 1. So if the character at this position is less than this position, it indicates that if we keep the character I, the string will be lexicographically smaller. Otherwise we will not keep the string this index I and I plus 1, and instead we will start our take the answer for I plus 2 index onwards, right? So in this way, we will make 2 to the power m length comparison. But and how many have to comparison we have to make? We have to make order of log of n base 2 comparison for comparing two string. And if we have to compare n string, so the complexity will be O of n log n, which will not exceed our time limit, right? So now we will gonna discuss how we compute hash and next in our string this thing. So now let us assume that we are at arbitrary position, arbitrary index si, right? So and the value at this index si will be say ai, right? So when we have to compute hash I, which will be the value of the hash of the string starting from index I for length 2 to the power 0, which is 1, will be simply the value of this character, which will say for the value for any character I will be ai. So as of hash of I comma 0 will be ai, and so we have calculated the hash of one length string. Now let us calculate the next I0. Next I0 denotes the position of the answer starting from index I after length 2 to the power 0, which will be just the next index, that is I plus 1, right? So now we have calculated this thing, hash of I0 and hash of I1, this next of I0. Now based on this calculation we will gonna compute hash of I1 and next of I1. So like now we have to calculate the hash of the string starting from index I of length 2 to the power 1, which is 2. So we know that the hash value will be like the one value a0 like ai, and then we will also know, because we are computing for this computing from the starting from the suffix side, so we know that the value of the hash should be like ai plus 1 and times a plus ai times some prime p. So in this way we know that it should be like that. So let us now compute this thing using this definition of hash ij. So hash ij or hash I1 will be the hash of the half part, that is hash of I now starting from index I, and length now it's not 2, length we will take for the half part to be 1, which is 2 to the power 0, and then plus, and we're going to multiply this by p. We have to multiply this with p to achieve this, plus what is this ai plus 1? Ai plus 1 is the value of the hash starting at position I plus 1. And what is I plus 1 position? I plus 1 position is simply the next I0, right? So hash of I1 is hash of I0 times P times hash of next of I0, right? And because this is the position, we have to compute the hash of, and then of length what? Of length 1, which is 0. So in this way we computed the hash of a string of length 2, that is aip plus ai plus 1. Now we will gonna, and we will also need another variable, that is next I1. Next I1 is what? Next I1 is the position in the string for the answer starting at position I, and also this starting position I, and also of length to the power 1, after length to the power 1, which will be I plus 2, right? Because I plus 1 is the first position and I plus 2 is the second position after the length, after the index I. So now we have computed the hash I1 and next I1. Based on this information, we will compute the hash and next of the string of length 4. So just a minute. Yeah, so now we will compute the hash I2. So hash of I2 will be the hash value of the index starting from index I of length to this power 2 to this power 1, which is to this power 2, which is 4. So hash I2 will be first of all the hash of the middle part plus other middle part. We know that the other middle part will be just simply we will take the hash of the first part and first middle part and the other middle part. So the first middle part will be hash, we will compute using this formula, that is hash of I1. In last case, when we compute a hash of I1, then we multiplied I0 by p raised to power 1. Now we will going to multiply this by double power, that is p raised to power 2. And also we will going to do the similar thing that we have done the last time, that is the hash of the next, that is the middle part, that is the index starting from the middle plus 1, that is hash next I1, which will be the I plus 2, right? So from the I plus 2 also we want the length up to 2 to the power 1, which is 1. So in this way, what is hash next I1 1, which is hash, this is hash starting from the position I plus 2, and we know that the value of the hash for length 1 for any index for the hash starting from index I. So we will going to use that information, this information, to calculate this hash I plus 2 I plus 2 1, which will be ai plus 2 times p multiplied by plus ai plus 3, right? So now what is the value of the hash I1? Hash I1 is computed here, ai times p plus ai plus 1. So we will want to just multiply it by p square. So when we multiply it by p square, we will get ai times p cube plus ai plus 1 times p square, that is ai times p cube plus ai plus 1 times p square. So if we compare this with our polynomial rolling hashing function, so it is exactly the same the thing that we need. So in this way, in general, if we we understand from here. Just a minute. Oh my goodness, why you are not erasing? Yeah. So in general, if we have hash ij, if we have, let us take hash of, let us take, we have to compute hash ij, and we have hash ij minus 1. So the hash of ij will be hash of ij minus 1, that denotes the, if we have to calculate for the full length to the power j, we will first of all take the half length, right, and then multiply it with some power of p, which will be power of p will be like ij minus 1. So this is a half length, so we'll multiply this half length by power p. When the length was 2, so we multiplied here by p square. When we have to compute, okay, when we have to compute p square, this I2, we have p square here. When we have 1 here, then we have p1 here. So it actually is p raised to power 2 raised to power j minus 1. So when our j was 2, so 2 to the power 2 minus 1, 2 minus 1 will be 2 minus 1 will be 1, so p to the power 2. When j was 1, that is 2 to the power 1 minus 1 0, so it was simply p to the power 2 to the power 0, which is p to the power 2 to the power 0 is 1, so p. So hash ij will be hash ij minus 1 times this power of p plus hash of. Now we will compute the hash from the middle part for length to half length. So the middle part will start at which index, which position? It will start at this position, that is next I, the same index it is beginning with, but up to half length only. That is the index after this position, half length, mid plus 1, and then hash of starting from this index to only half length, that is j minus 1. So in this way our hash is computed for ij. And how the next ij is computed? Next ij is simply next ij. To compute next ij, what we can do, if we have to compute the value of the position after the length to the power j, what we can do, we can compute this value of using this formula, that is next. We can compute first of all the middle index, which will be next I and j minus 1. This will be mid plus 1. So this is the position of mid plus 1, and after that, after this position, so from the mid position, what we can compute, we can compute from the mid position for the length j minus 1. My goodness, yeah, from the mid position we can compute for the length after the length to the power j minus 1. So that will give us the full next ij. In intuition, if we want to take the intuition of it, what is this happening is exactly is this. So what is next ij? So let us take this is our length. Oh my goodness, this is our length and this is our middle, right? So next ij will be after this length, this position, right? This position. So next ij starting from this index I will be next. First of all, what is this next ij minus 1? Next ij minus 1 is the position after the length to the power j minus 1, which is position after this middle part here. And from here we will compute other the index after the length, after the again this to the power j minus 1, which is the this whole middle length. So which will make it come here. So is so if we have to compute this from this, we can compute this from this in this way, that we can go first of all here, and then from here to here we can jump. This is actually a shifting, binary shifting, as I think this thing we also do in the trees for calculating the LCA, lowest common ancestor. So in this way we compute the next ij. What is hash ij? What is the intuition behind hash ij? Hash ij is simply like after the next position, after the middle position, what will the hash of the length, this length, half length. And we know, if we know half length already, because we will come from come into this tab from the last tab. So we will already know the half length. So we will multiply this first factor with the power of p to be 2 to the power, if the length is I, the full length is I, so we will multiply it by p raised to power 2 raised to power I minus 1 to compute the hash. So in this way we're going to solve this problem. Now let us look at the code to understand it a little bit better. So in this code, so yeah, this is also one thing we have to understand. Yeah, so I told you here that we will compute when we have to compare the two strings. We will compare them with their hash values up to length 2 to the power some length. What that 2 to the power some length will be, we will compare them for the length 2 to the power m minus 1 in such a way that 2 to the power m will be greater than n, and 2 to the power m minus 1 is less than equal to n. So we will just always so that this length will always be less than n. So, and this is the largest length which is less than n. So we will take this length 2 to the power m minus 1 when we will compare the from the for position I and I plus 1. So we will compare up to this length, and then we will drop this to m minus 1 to 2m minus 2 all the way to 2 to the power 0. and we know that the summation of this will definitely be greater than will be around 2 to the power m, and which will be greater than n. So definitely this will be greater than n always. So in this way, so now let us look at the code to understand it a little bit better. This is the same code actually used by the author, but I was just modified in my way. So we will input our string, and then we have this vector of the values of the corresponding character of the string. What is the corresponding character value, which is equal to si minus the a character plus 1, and then we will compute the largest length, largest value of m, up to which 2 to the power m minus 1 is like less than or equal to n. And after that we will take this prime number p to be 29, and then what we are doing is like calculating the value of the prime number powers for power up to n plus 1, up to n actually. So power of 0 is 1, power of I is I minus 1 power times p, and then we have this vector of hash and next, and then we have this for the answer. This length denotes the length of the answer starting from index I, and then this is the starting index, that is the beginning index for each of the index. For initially we will initialize this index, beginning index, to I for any index I. For 0 to n plus 1 we are initializing, and also we are initializing our this next with n, so that our hash of n will n plus 1, and this our hash for this after this length n will always be 0, because let us assume that we have to calculate this value of the hash of length 2 to the power m minus 1 for the last index. Then we know that there are no 2 to the power m minus length after the last index, so in this way we just multiplied it by 0 only. So that we will see. Let us it is just not that difficult thing. You can just assume that we have to update these things. So now we have this function which is comparing the two strings at index I and I plus 1, and this is the function, update function is used to calculate the value of the hash and the next. And now when we come here, we will go from the suffix, and then we will start from the index I minus 1 all the way to 0. So then we will update I and I plus 1, that is we will gonna compute the hash value and the next value starting from index I and I plus 1 up to length 2 to the power m minus 1. So here we will come in the update, and then we'll say the length for the this length, answer for this length will be answer for this length plus 1, because we're including this index x, and then hash of x0 will be simply ax, which I have already discussed, and next of x0 is I plus 1, which is actually v. In this case it is v, I plus 1 is v. So after that we will compute next ij, next xi is next of next xi minus 1, which is similar to LCA times, and then this is I minus 1. Further we will go to half middle part, we will go further on a shift binary to the other middle part, and then we'll compute the hash value using the formula we have discussed. Hash xi will be hash xi minus 1 times multiplied by the power of p, which is 2 to the power I minus 1, plus hash of the middle plus 1 position and up to length I minus 1. So after updating this, if we find that our ai is equal to a plus 1 and our comparator I plus 2 comma I is true, comparator of I plus 2 comma I is true denotes that the string starting from index I plus 2 is lexicographically smaller than the string starting at index I. So then we will gonna begin put set our beginning index from I to I plus 2, and length starting from index I to length starting from index I plus 2. So what the comparator function does is, like for example we have to compare index I and I plus 1. Here it is x and y. So what we're going to do, we will compare their hash for the largest length 2 to the power m minus 1. If they are equal, we will going to shift that to the next position x and y, up to we will compare up to the point when their hashes are not equal. When their hashes are not equal, we will just simply compare the values at those positions ax and ay. If ax is less than ay, it means that the position I is less than I plus this I plus 2. So I is less than I plus 2, but here we are using I plus 2 and I, so that is the inverse of that. So after that we know the now answer of all the things, so we have to just output the answer. So we will output the length, and then we will for any position I or x, the beginning index will be is equal to beginning, its first index will be the beginning index of I, and after that if the length is more than 10, there is a one condition in the problem, that if the length is more than 10, then we have to just output the first 5 characters. So this is this check, and first position will be the first value will be the value of the string at the beginning index, that is s of x, and after that we're going to shift the x to the one next character, that is next x comma 0, which is the position in the string after length to the power 0. Again, we will keep shifting this up to for the length 5. After that, the extra length, which is if there is extra length beyond 10, that will be like, because we have to output other two characters as well, so we have to subtract that other and two as well from the length. So these are the additional characters. We have to erase those characters. But how we're going to erase this? We're going to erase this using the power of 2. So using the power of 2, we're going to decrease this value. And if this is decreasing, so in that case, it means that we are shifting. How much we are shifting? We are shifting by 2 to the power I. And after that, we'll just output this string, and then we will output for the remaining characters the second last character, and then we will want to shift it by one more length to reach the last character. In this way, we're going to output the whole string. So I hope you understand some part of it, if not all the part. With this note, I will terminate now.